In this video, we look into what is the mathematical formula for an ellipse, what is an ellipse, and how are we going to look into that. All right. So let's not do the entire derivation for now. Let's understand what is an ellipse first. Fair enough. See, we are going to understand one of the conic sections, ellipse. Now, let's try to understand what is an ellipse in a geometrical way. Okay, before we enter into the algebraic form, or we can say the Cartesian form, let's try to understand the geometric form. See, what we have is, suppose say you have a cone. Okay, imagine you have a cone like this. For this particular cone, if you cut the cone like this, you see, if you cut the cone like this, try to imagine this in 3 dimension. What figure do you get? That is an ellipse. All right, so this might, I'm sure that you guys know this one, right? So how we are going to get an ellipse? So mathematically, like geometrically, not mathematically, geometrically, an ellipse will look something like this. In other words, in common terms, when we call it, an ellipse is basically an oval. All right. So since you have this ellipse, now I'm sure all of you would have heard about this in Kepler's law, at least back in your schools and everything. Kepler's law is Earth moves in an elliptical orbit. So that ellipse, this is an ellipse. Now let's do and understand that what are the parts of an ellipse? What do we have in an ellipse? All right. Now assume that you have an ellipse. All right. So let's assume that this is the ellipse what we have. Okay. Now what you're seeing, that every figure is placed on the x and y axis, correct? So first what we'll do, we'll place the x axis here. So x axis is placed in such a way that it is dividing the ellipse into two equal areas, as you can see in the figure, correct? So when you have this one, so what we'll do, we'll name the points here. Okay, so we'll name the points. Let's call this as A. All right, and let's call this as A dash. Fair enough. Now there is a distance between A dash, correct? See this entire distance. This entire distance. This distance, whatever we have, we'll call it in a different way and we'll name it in a different way. That means we'll call this particular axis as the major axis of an ellipse. Why major? Because the area has been divided into two equal parts, and that too, it's the bigger area. Now you might be thinking, what is a smaller area now? Now think about it. One, you're cutting it horizontally. What if you cut it vertically? Right? So now what we'll do, the same thing, we are going to take a line. Same thing, we are going to take a line. We'll make perpendicular now. So we'll go for 90 degree. All right. So keep it here. Now, how are we keeping it? We are keeping in such a way that the ellipse is exactly on the origin. That means the x-axis will be the major axis, and the axis what I'm about to write now here. What you see, this also divides the ellipse into two parts, right? But the smaller region. That's why when we write this call it as B. Let's call this as B dash. Now when I say smaller and bigger region, guys, don't think it like, oh, but the area is the same, because anyway we are dividing it into two, right? That's not what I'm talking about. Okay, I'm talking about the orientation of the ellipse. There is a slight difference between them. All right. Now we have B and B dash. Now in this case, the distance between B dash, we are going to have some value here, correct? Between these two values. Now the axis, this axis is the minor axis. All right, minor and major. Now a very important point is, from the origin what we have, see this is the origin O, right? From O to A, this distance, this is what we call as semi-major axis. Semi-major axis. Okay, so we can write it here. OA, this is semi-major axis. Likewise, OB becomes semi-minor axis. So when I say semi, it's always half, correct? So generally what do? O to A, we'll call this distance as A. That means OA dash will also be A, correct? Again, magnitude wise, don't take oh, this is minus A, what do we go about it? You know, in coordinate system, minus is to the left side or below, correct? So A and A. So that A dash, what we have? Okay, so A dash, which is the major axis, that distance is 2A, right? Same way, B dash becomes 2B. So the major axis length of an ellipse is 2A and the minor axis is 2B. Fair enough? So we have the semi-major axis, semi-minor axis, and then major axis, minor axis, and everything. Well and good. Now see that point O, what we call as the center, the origin. That point O is called as the vertex of the ellipse. Fair enough? That's a vertex of the ellipse. Now there are two other important points in an ellipse. We'll look into that now. Alright? The other two important points, apart from the vertex, are 2 points here. One is here, one more is here. Alright, so these 2 points are called as the foci or foci, depending, both are one and the same. Alright, so we'll call this as F1, we'll call this as F2. Fair enough? So from the vertex O, the F1 and F2, they are equidistant. Okay, but they are not the midpoints as you can see in the figure, they are never the midpoints. Fair enough? So F1, we can call that F1. F1, you can say minus C, comma 0, and F2 is C, comma 0. And of course, O is nothing but 0, comma 0. So 3 important points in an ellipse. Foci, 2 of them. Vertex, 1 of them. Alright. Then 2 major distances. Major axis. So we can say major axis. Sorry. So we have major axis. This is 2A. And minor axis. This is 2B. Isn't it? So 2 important lines. So any point on the ellipse, it is moving in that elliptical path, correct? It moves in a particular fashion. So how it moves, what exactly it does, and the mathematical form, we are going to understand these things in the next video.